Saxon Algebra 1, Lesson 29. This is a two-part lesson, and you guys, it's kind of a fun one. It's straightforward, to the point. It's algebra. There's no drama. We'll get right to it. Before we do that, though, I just want to remind Jackson, you owe me a picture of your mom's signature, and Eli, you needed to get yours signed as well. So if you have not done so already, please get those to me. All right, negative exponents. What the heck is that? Let's say we have any random base. We're just going to call it x. And there's an exponent on it. We'll just call it n. This is just to say, this is how we write rules. Instead of using numbers, we put letters in so that they're just kind of generic. If there's a minus sign in front of the exponent, it means something weird. This is how I think of it. It's a trapeze bar. You know in the circus how the dudes hang on, or ladies too, the trapeze artists of either gender hold on to the bar and then they flip around. Well, that's what negative exponents remind us, because what they do is they flip our base down into its reciprocal, right? This x on the top became an x on the bottom, and the n came along, but the minus sign gets burned up in the flipping. All right, the trapeze goes away. Once we flip it, it's done. So this is how we handle negative exponents. We can do this in either direction. So for example, if we're starting with this, oh, I wrote on my finger in the Algebra 1/2 lesson. You can tell because it's blue. Everybody's got their own color, or I would go crazy. Okay, so if we start with this is okay. We can change it to that if we want. We can bring it up. The other thing is that if we have a negative in the bottom, then that becomes a positive when you flip it up. So again, the act of flipping burns up the trapeze and kind of resolves it so you don't have to deal with it anymore. All right, so those are our rules. Let's look at some problems. There's quite a few problems in this. Excuse me. There's quite a few problems in this lesson, but they're very short. Simplify. 3 to the minus 2. Okay, we follow this pattern. That means it's 1 over 3 squared. That means it's 1 over 9. Yay, done. I mean, that one was really easy, right? They're not going to get a whole lot worse. Example 29.2 looks like this. 1 over 3 to the minus 3. Okay, this looks more like this one, doesn't it? So we remember, oh yeah, this is one where we'll flip it up. It'll be 3 cubed, and that's 27. Huh. All right. Cool. Example 29.3. P.S. If you haven't done so already, I'm just going to wait here for a second. Please copy both of these into the cover of your notebook right now. Okay, I will sit here and stare at the wall for a good 30 seconds while you copy it. Go. If you need more time, feel free to pause me, but I'm going to go ahead. Okay, third example. All right, now John's getting a little crazy because we've got the minus sign up here and then the minus sign in here on the base, right? This minus sign's on the base, this one's on the exponent. They mean two completely different things. This guy's the trapeze. This one is just a drama minus sign like all the other ones we're used to dealing with. This one is protected by parentheses, so we can't get in there and cover that up. That means that this minus sign is going along for the ride. So we're going to say, first we'll deal with the trapeze. 1 over minus 3 squared, right? Notice how I don't worry about this one first. I take care of the trapeze. Now that the trapeze is settled, I can go, okay, this is minus 3 times minus 3, right? The minus sign is, I can't get in there and cover it up, so that becomes positive 9. Yay. What about this? X to the fourth. This one's a long line. Ready? M to the 2, x to the minus 2. M to the minus 5. All right, so in this one, we don't need necessarily to use, we don't need to fix the negative exponents. What we want to do instead is use the product rule for exponents, which if you may recall, it's if we're multiplying matching bases that have exponents on them, we can add those exponents together, right? Well, that works in something like this. So we can say, okay, here's an x with a 4, here's an x with a minus 2. So 4 plus minus 2 is x squared. And m squared times m to the minus 5, that means we take 2 and add a minus 5, so that would be m to the minus 3. That is our answer, okay? So sometimes when we have negative exponents, we don't necessarily get rid of them, but we combine them using this product rule for exponents. We can just combine them and leave them in this form. If we wanted to, we could rewrite this as x squared, and then we could flip m to the third down on his trapeze. See, this guy got flipped down, this guy stays up. This is another answer for this problem that's equally acceptable. Here's the thing about negative exponents. They aren't necessarily bad. So we don't have to make them go away if we don't want to. Good to know. Okay, one more in this topic, and then we switch to our second topic. Example 29.5. It's a longer row. Are you ready? Those are my z's, remember, they look weird. We're trying to simplify this. Again, we're going to use the product rule that tells us if we're multiplying matching bases, we can add the exponents. So let's take a look. Let's go alphabetical. There's an x, there's an x, there's an x. This x doesn't have an exponent. What are we going to do about that? Oh, right. If there's no exponent, we can put a 1. So here we now can add these three numbers together and get a final exponent for our x. Minus 2 plus 4. This is what I'm going to write. Minus 2 plus 4 plus 1. Notice what I'm doing is I wrote the base here, and then I'm just writing all the exponents, and that will be 3, won't it? Good. Now I'm going to do the next base. Let's take all of those. It's just the 2. There's no other y's, right? That's correct. Minus 6 and 5. All right, there's the minus 6 and there's the 5. So that equals minus 1. And then our z is another invisible one. Let's add that. 1 plus 5. Notice that I'm adding all of these. It's just some of them I'm adding a negative number. So this equals 6. So for my final answer, I write x, this base, to the third. Y is the next base. That's the ending exponent. That's the combined exponent. And z to the 6th. That's my final answer. And that's correct. Okay, so we're perfectly fine with that minus sign being there, that negative exponent. It's fine, we just use the product rule to combine. And this is more of like a worksheet, right? Where we write the base and then all the exponents we have and combine them. The base, the combined exponents, and then the base. again. And then we take this information to make our answer. Yay, 29.5. Okay, that's enough about negative exponents. Now we're going to talk about the second topic, which is zero exponents. We know that there's such a thing as a 1 for an exponent, and we can put that on whenever there isn't an exponent otherwise. And we know that you can have positives and negatives, but what's with a zero exponent? Oh my gosh, it's the easiest rule in the world. Anytime you raise a number to the 0 power, it's equal to 1. Period. The end. That's really cute, isn't it? Okay, let's try a couple of these problems. John's doing the cheating thing where he's doing an A and a B. I don't understand why he thinks that's okay. Okay, ready? X squared, y to the 5th. I'm not going to talk, you can copy. X to the minus 2. Okay, so I'm sorry, I don't know why I drew a line under it. Let's do this just like we did it last time, only I'm not going to write out that big, well, no, I will. Let's do the base of x first. We've got a positive 2, and then we're going to add a negative 2. What? 2 and negative 2, that adds to 0. Okay, let's do the y's before we freak out. It's 5 plus negative 2, right? So that would be 3. But this, x to the 0 power, y to the 3, we don't even, y cubed we can say too. We don't even write that. Our final answer is just y to the 3rd, okay? So the base of y disappears because we ended up with a 0 exponent. So essentially it canceled itself out. And our final answer is just y to the 3rd. That was part A. Here comes part B. M to the 5th, b squared, mb to the minus 2. Again, a lot of students find it really helpful to just fill in any missing exponents with a 1. Not a 0, a 1. Okay, let's try doing this one in our head. Instead of writing out the chart, let's just look at the m's. No, let's go alphabetical. B plus 2 minus 2. Okay, that's b to the 0. Turns into a 1. We don't even have to write it down. M to the 6th, right? 1 plus 5. So that's our final answer, right? Because the b's add up to b to the 0. B to the 0 equals 1. Don't even have to write it down. All right. Oh, now John's going to just amp it up one more step. Use the distributive property to expand. All right. We will. Now, I'm going to write it down as it is in the book. X to the 5th, y to the 0, z times p. Sorry, I don't know why I say it out loud. I know it doesn't help you. It just probably annoys you. Okay, I copied it just the way it was in the book. I'll be quiet and let you finish copying. I think you need more time. All right. As we copied, we noticed that there were 2 bases that have an exponent of 0. We can just drop them from the calculation right away. I'm going to put a 1 here so that I see it. And while we could leave these in, it's absolutely 100% fine just to drop them out right at the very beginning. We don't even need them. So now we can tackle the problem. I'm just going to draw a couple more lines in there so that it visually doesn't trick me. Ready? Now we're ready to multiply the outside times the first term. Let's go alphabetical. It's p to the minus 3, x to the 5th, z. I won't write z to the 1st. Okay, so that's what we have for the first one. Then, now let's do the second one. It's going to be minus, it's going to be 4. Oh, and now look what happens. X to the 5th times x to the minus 5. We're multiplying the bases, so we add the exponents. 5 minus 5 is 0, so x drops off. And look at z. Z to the 1 and z to the minus 1, that drops off. So our final answer is p to the minus 3, x to the 5th, z minus 4. That's correct. Okay, so we canceled out some of those zero-powered bases right away, and then we had a couple more crop up as we distributed, and we could just ignore them. So here is the truth, you guys. This is your friend. This makes your life so easy because you can just drop those out. Okay, let's try another one. Oh, look, we're on our last page. And I wrote notes on it, so I'm going to rip a page out of the Algebra 2 book. Don't worry, I have another notebook. Did you think we would have to be done with math for a year because I ran out of paper in my notebook? That'd be awesome. I mean, no, it wouldn't. What am I saying? I would be so sad if I couldn't make you these amazing videos and send them to you. What would my life be without you? So boring. I just sit here every night talking to myself, so can't have that. All right, we'll finish up on this loose piece of paper, and then next time we'll start the new notebook. Use the distributive property to expand. Okay, so same instructions. We have this problem and then one more. Okay, ready? I'm going to write it down. X to the minus 2, y to the minus 2, times x squared, y squared, plus, sorry, I'm doing it again. Why do I always do that? This is to the 4th. Okay, so that's the exponent on the x. Ready? So we're going to do this, and then we're going to do this. All right. Go alphabetical. X times x, multiplying the bases, add the exponents, minus 2 plus 2. It turns to 1, it poofs, and it's gone. Let's try the y base. Y times y, that means we add these. Minus 2 plus 2 equals y to the 0. Poof, it's gone. Now, some students want to write down a 0 for that. But that's wrong. These guys didn't completely, well, they disappeared, but before they disappeared, they turned into 1s. So the right answer here is 1, right? This becomes a 1 because, let me just write it out again, x to the 0 equals 1, not 0. So there's the 1 that we get when both of those cancel out. Here's the plus sign. Now we're going to do this. 4 is good. X, I have a minus 2 plus 4, that's x squared. And look, y passes out too, right? Becomes y to the 0, so it's equal to 1. I don't have to write it down because there are other coefficients in that product that are holding the place for me. This one, everything went away, so we had to add the 1. So that's a very important lesson for you, is that it doesn't go away altogether, it just becomes a 1. Okay, and if we've got other guys being multiplied, we don't have to write it down, but if everything else is gone, then we just put the 1. I hope that made sense. I want to see your faces right now and see if you're giving me a, what in the world are you talking about? Or, yes, we get it, move on. I'm going to assume the latter. Okay, ready? Simplify. A. 2 to the 0. Okay, well, this is like what we've been doing, right? It doesn't matter if it's a letter or a number. If the base is being raised to the power of 0, the answer is 1. This one's the tricky one. I want to skip B, and I want to do C. Okay, here again, we have a base, and notice that this minus sign is part of the base. The parentheses are attaching it to that minus 2. So when I raise it to the 0 power, all of that goes away, and it just becomes a 1. This one is the tricky one. Because there are not parentheses protecting that, we can cover it up. 2 to the 0 power equals 1, but when we lift off our finger, oh, look. It's actually a minus 1. So A and C are 1, B is minus 1. This is super tricky, you guys. And you definitely want to lock that into your bag of tricks because you'll run into this in a problem. Remember, if it's not protected by parentheses, we can cover it up, simplify that much, and then there it is again. But this one, we can't get at it. So this all turns into a 1. Guess what? We're done with lesson 29. Yay! Goodbye, I'll see you for lesson 30 very soon.